I have another very trivial demo just to show what happens and what sometimes people get confused by. So we have this local I, and I'm going to test to see if it's 3 or not. And if it is, I'm going to print out that I is 3. You would expect when I run this that this would not print out that I is 3. Then I'm going to print out the value of I again. You'll see that it's 2. And we're going to test again, but here I'm making a, quote, mistake, unquote, of using a single equal sign rather than a double. If this returns true, I'll print out that I is 3, and then I'll deliberately set it equal to 4, hoping then for a failed comparison. And now here I have a kind of a backwards comparison. People sometimes call this Yoda syntax. And I'm comparing 3 to I instead of I to 3. Either way, it should come out false, so we should expect not to see I is 3. Let's run this. And I'll just put the output next to the code. Let's say we start out and I is not equal to 3, so we don't print this line out. The first thing we print out is that I is 2. The next thing that happens is that suddenly we're told, yep, I is 3. The reason is that this I equals 3 line actually assigns the value 3 to I. Compiler does exactly as it's told, puts the value 3 into I. The equals operation returns 3, the value it just put into I. And since 3 isn't 0, that's converted to Boolean true. The if succeeds and the statement I equals 3 prints out. Here we pump out the value of I again to confirm that, sure enough, it is 3. Then we deliberately set it to 4, and testing here, it doesn't print out I equals 3. We printed out the value is still 4. Well, why would anybody write their ifs this way, 3 equals I? The answer is what happens when you make this mistake. Here, when I make this mistake, I still get valid C++ code. This is actually something that happens quite often in real code on purpose. But here, if I take away one of the equal signs, you can't set the number 3 to a new value, so you get a compiler error. And people who are fans of the Yoda syntax are trying to prevent themselves from this error by using their syntax in this order, so that if they ever just forget and type a single equal sign, that they'll get helped by the compiler. Let me just show you, I said this is something people would actually really do, have a single equal sign and an if. I'm going to type some kind of gibberish code. I'm going to call some non-existent functions and prove to you how people might do this. So something you might do, you might declare another integer, call some function, passing in a string, and then if that p is not 0, do something, call some other function. Let's just make this true-ish, at least keep the compiler happy, by just declaring some functions. I'm going to have an integer foo that takes a string s, and in order for that to work I have to include string. And another integer function called something that doesn't take any parameters. I'm not going to implement these, but simply by declaring them this way, I take away any red wigglies and make it clear to everybody that the compiler is okay with this code. Now let's make it a little nicer. Let's put the braces here no matter what, so that if we add more into what we're going to do when p is not 0, that we won't get messed up by thinking the compiler might read our indents. This is working code. The compiler will compile it, it'll run, assuming I were to have the functions foo and something written, but it's not kind of C++-ish. The first thing is to take this away. It's very non-C++ish to write if whatever equals true, or if whatever is not 0, because they're the same as just if whatever. So when I say if p, that will come out as false if p is 0, otherwise it'll come out true. So if p and if p are not equal to 0, exactly the same. So this is the more C++ way to do it. And the really more C++ way to do it is to take this assignment and put it here. Now I'm in the one breath assigning p to the result of the function call and checking the result of the function call. If it's non-zero, we'll do something. If it's 0, we won't. And this is a C++ idiom that happens all of the time. And for the compiler to warn you when you did this and say, oh, are you sure? Did you really mean to type only one equal sign? Would mess this idiom up. So as a result, there's no warnings. You see there's no red wigglies. And if I were to build this, I would only get linker errors because I haven't actually implemented those functions, but I wouldn't get any compiler errors at all. And I'm going to take this code and just comment it out. And then uncomment some other code that I want you to see. This code is going to ask for a number and figure out if it's prime or not. So we're going to use the isPrime function that's been kicking around in a lot of different demos and the not operator. So isPrime will return true when it's prime. Not will turn that into false. It'll return false when it isn't prime, and notting that will turn that into true, which in this case will cause it to print out not. So it'll write out either 4 is not prime or 5 is prime, depending on the number that I enter. So that's showing you combining the results of a function with the not operator right inside the if. I'm then going to ask for a second number, j, and I'm going to calculate I mod j, that is the modulus, the remainder, after dividing I by j. So if I is 5 and j is 2, 5 divided by 2 has a remainder of 1. If the remainder is exactly 0, then they're multiples. Right? So if I take 4 divided by 2, that has a remainder of 0, that's because 4 is a multiple of 2. And I've written this out the long way, saying if it's not 0, then it's not a multiple. But again, the more C++ way to do it would simply be to test I mod j. If I mod j is 0, that's false, and we won't go into the if. If I mod j is non-zero, that's true, and we will go into the if and print out the not. So I'm going to run this code and try it with a couple different numbers. So let's try 5 and 2. 5 is not a multiple of 2, hopefully not a surprise to anybody. Run it again. This time I'll do 4 and 2. 4 is a multiple of 2. Let me show you one other possibility. I'll try 5 again. This time I'm going to ask if it's a multiple of 0. You see what happens? We sort of sit here, and then Windows says, your program has a major problem. And the major problem is that it's thrown a divide by 0 exception, which I could figure out if I were to click Problem Details and scroll through and take a look at the problem. But there's no way to solve it, and I'm not going to submit details. We divided by 0 because I entered 0 for the second number, which is j. There are a variety of ways to cope with that. I could have put in a while loop that said, while the person didn't enter 0, and if I do enter 0, I could put an error message, ask me again, and so on. And honestly, taking the modulus like this may not be the world's most common behavior, but there are plenty of functions out there that expect to get a number that is not 0. And passing 0 will make the function blow up. So we can simulate that with this I mod j calculation. And if I simply say here, if j and I mod j, what's going to happen is when j is 0, that's false, we shortcut, we won't calculate I mod j, we won't throw the arithmetic exception. Now we also won't print out the word not, so this is going to have the consequence that everything can be a multiple of 0. If you don't like that mathematically, you could write a slightly more complicated version of the expression here, but I'm okay with everything being a multiple of 0. So let's run this now and say 0 and watch it not blow up. So I'll say 5 for the first one again, 0 for the second one, and it reports that 5 is a multiple of 0. You may not like that mathematically, but what's important here is the application did not blow up. And the reason it didn't blow up is that this line, which tried to divide by the second number, this expression was never evaluated. And it was never evaluated because the AND is a shortcutting operator.